At this session, we're going to talk about the nested families and also the principles and rules that you need to put them into the consideration. First of all, if you want to create a family, like the last session's shelves, first of all, we should open a new template family file. Here we can either choose metric generic models or even you can use furnitures. At this context, there is no difference between these two template files. But if we go further, if you want to model an escalator, choosing the correct template file is important. In a way that it is important to choose generic models. Since the generic template files are cuttable, they are able to be cut, but furniture template files are not cuttable. And you should know this point. For instance, if you're going to model an escalator by using furniture template file, there you won't be able to add cuts or sections. If you use metric generic model template file, you got no limitation in cutting. Then I will teach you how to display it by a dotted line. While if you use, for example, components, there you will have some limitations in using cuts and sections. So there you will have some challenges. I just want to tell you there are such details like this, and you should keep them in your minds. I open generic models by this way, very well. Here I pick extrusion, and then by using rectangle, check this out. Then I measure the distance to place the dimensions, and then I equalize it in both sides for having width and depth, both equalized, and then the total dimensions by this way. I associate the parameter, I name it depth as you can see, and then the next one I select it to create a new parameter, width. Am I right? Very well. Finish. In a very simple process, we can even control the thickness by associated to a parameter. I sketch the reference plane by this way. I align it with the reference plane and then I constrain them. I place the dimension and then I associate it to a new parameter, T as thickness. And to just save my time, I'm going on quickly. Let me test the parameters. Don't forget to test the parameters. Well done. At such a condition, if I want to make it a little bit complicated, I'm gonna create an opening in a specific position in order to pass an item through the extrusion, create a void or an opening. Then I want the void to occupy 1/3 of the geometry. For instance, at the left side of the geometry or extrusion. What should I do? Let's see. Here in the reference level plan view, and if I want to divide the geometry into 3 parts and then occupy 1/3 of it for the void, I should divide the geometry firstly into 3 parts. Here the thing that I can do is to sketch a reference plane right here, as you can see, as I'm showing in the scene, and then divide the extrusion into 3 parts. But preferably, if I want to do this, for now I delete these by this way, and then I sketch the reference plane and have them locked by this way. Am I right? Well done. As you can see, the geometry is locked to the reference planes. And then the distance or the dimensions, since sketching the reference planes, as I told you last session, stands at the first priority, equalized, and then the other side. Actually, I forgot to sketch reference here. I have been always emphasizing on reference planes. One of the features of a standard family is having too many reference planes, since it shows the accuracy of the family. Actually, the parameter does exist. Both of them do exist, but I need to associate them, depth, and the other one I select it and then I associate it to width. Very well. Then I need 1/3 of the extrusion. Here I'm gonna sketch a reference plane right here, by this way, and the other one there. Then I measure the distance, which is equal to the width, And then I equalize the three parts. I mean the dimensions or the distances in the two sides are equal, and also the distances in the three parts are equal to each other as well. So we got access to 1/3 of the geometry. And these two references, I measure the distance, align distance, equalize three parts. So here is 1/3 of the geometry. Here we can delete the dimensions and then associate the parameters only to 1/3 part of the geometry, so that we can control the size of the void, for example, or the opening, by making the geometry parametric. So for creating an opening, I pick circle and I sketch it right here. I want to associate a parameter to the size of the radius. I name it, for example, hole R or hole radius. Well done. It is parametric, but however we can associate the circle to the reference planes, which are in the 1/3 part of the geometry. Most of the time it is automatically associated. I modify white. As you can see, circle is constrained to the reference plane, so it is smart. 900. Check this out. It is aligned with the reference planes. But just in case, if I select the circle and then I check center mark visible, then the center mark of the circle will be displayed, as you can see, which allows you to constrain or lock the circle to the reference planes. So center mark visible is a significant option here. By this way, the circle is constrained. Well done. I click on finish. Let's check it out. In family types, 3000s, apply, still at 1/3, 1200s for depth. You can modify the hole radius, 120. Check it out, like this way. And the thickness, again I'm gonna emphasizing on testing the parameters. Let us check it in 3D view. Testing thickness. As you can see, the parameters are working correctly. And if you agree, let's associate a parameter to the material. How can I associate parameter to the material? In material, I should click on associate family parameter to modify the by category. However, there are some other properties that you can create your own parameters and then associate the family parameters. Check this out. For example, extrusion and then start. Associating parameters to the subcategory and the solid or void are not available. I mean the properties in identity data do not have the capability to become parametric. I associate the parameter to the material. Let's review, and then instead of getting access to a new parameter in the labels, here we can create new parameter. I click on it, then I assign the name of my new parameter. For example, I can assign it panel. The panels which are used for the flooring, and I click on OK. Well done. So during the process we have created an independent object, and then we want to load it into project. But before that, let me save the file as panel, save, and then I load it into project, which is the another family template file, because this is considered as a nested family, gonna be used inside the another family, which is here. Check this out. Here there is a point that you should know, so watch this part carefully. Here when I load an object, the object is capable to be aligned with some of other objects, but from specific sides. As you can see, we got 3 reference planes. Here, wherever we got reference planes, you're allowed to align it with other objects. Since, as I told you before, we use the reference planes as a medium to align 2 different objects to each other, or with each other. Check this out, the exactly places that we got reference plane. Aligning is available, so there are some limitations in aligning. So the places in which we got reference planes, you can align other objects to the reference planes. So if you wanted to align your object to the another object, you should use reference planes as a medium here between these 2 objects to be able to align these 2 objects with each other. Right now I want to place this panel right here in the center, or at the center. I pick align tool. I align the panel to the center and then I constrain it, lock it by this way. then I align the horizontal lines by this way. And here, as you can see, by accident, the values of width in the two families are equal to each other, and it wasn't expected actually. But here the point is that to associate the parameters of the loaded family to the parameters of the host family. The panel is the nested family, the another one is the host family. First of all, I select the nested family. I open edit type to associate the families to each other. I want you to watch this part carefully, since I'm gonna deal with some other basic parts of Revit. Here, as you can see, we got the dimensions parameters which are related to the nested family that just be loaded here. As you can see, depth, hole R, T and width, which are hosted by this family, I mean the previous family actually. Among the parameters of the loaded family, we got depth, the radius of the hole, thickness and width. Following that, I'm gonna associate the dimensions parameters to the corresponding dimensions parameters of the host family. For example, associating depth to depth and width to width. But hole radius has got no corresponding unlikely thickness, but we got width and depth. So I associate width to the width of the host family by this way. As you can see, they are associated to each other. And the next one is depth, so I associate it to depth of the host family. Let's check it out. Here, as you can see, we got the edge distances, but we do not have the panel depth. At such a condition, you may want to associate a new parameter. So I sketch the align dimension by this way, and then I want to create the parameter. Check it out. For instance, I name it panel depth by this way. Panel depth. Okay. An error message is displayed that reference planes are over-constrained. I want you to memorize this error message, since I will tell you the reason later. What about the message? As you can see, reference planes are over-constrained. It means that the measured distance have already been measured, but there is no dimensions here, as you can see. But if we look at closely here, we get the value of depth and also the edge distances. If we subtract the total values of the edge distances from the value of depth, then we can have the value of panel depth. So because of this, we are not allowed to specify a dimension. But here we got two ways. The first, we can calculate the dimension indirectly by subtracting the total values of edge distances from depth. But what about the second one? As I told you, at first, we can compute or calculate the value of panel depth indirectly by subtracting the values of edge distances from the depth. Let me delete this from here, and then I'm gonna create a new parameter by this way. I specify the name panel depth. Okay. Then I'm gonna define a formula for panel depth in formula. So I copy width by this way. I paste it there in formula. Then I subtract it from the edge distances. 2 multiple in edge distance by this way. Inside an enclosed parenthesis. Check this out, the value is computed indirectly. So at this part, I didn't create a new parameter. I didn't measure a new distance. I just did specify it and calculate it indirectly by defining a formula, as you can see. Subtract width from the edge distances. Or you can open the edit type of nested family and then associate the depth to the panel depth in order to make them equal to each other, and then this would be the result. I think I made a mistake. Let me check the family types. Let me check the formula. Oh, I'm sorry. I should replace the width and edge distance. So I should remove width and then type depth instead of width. This is correct. Let's check it out. Well done. This is the depth of the panel. All in all, I want to say that this was my recommended approach for calculating the panel depth. What about the second approach? I deleted. However, the second approach is not recommended, but I tell you, I place the dimension at first, then I click on new parameter, then I want to create this parameter as an instance parameter, and also I check reporting parameter. But what is the reporting parameter? Here, as you can see, it can be used to exact value from a geometric condition and report it into the formula or as a scheduled parameter. In other words, reporting parameters are dependent to other parameters. They are only reporting a value which is dependent to other parameters. So if you want to control the reporting parameters, you should work on the parameters which reporting parameter is dependent to. So it's important, its only job is to report the value. And it reports the value from a geometric condition and a report from a specific formula. For example, I name it panel depth, and you cannot control the reporting parameters. If I check family types, look, as you can see, report is mentioned here, and if you define a formula to your parameters, they will be transparent because it means that they are controlled by other parameters. For example, the subtraction is associated to the value of panel depth. Well done. By the way, if you wanted to delete the parameters, you can open edit types and then click on delete parameters. By this way and OK. Anyway, here we got a problem. Let's solve it. Let me align the extrusion by this way with the reference planes. I place it right here and then I lock it. Well done. Actually, here I should control the value of hole radius, since it is not appropriate in relation to the size of the panel. So I open its family, edit family, then in the dimensions. Later I will talk about the conditional formulas in future sessions. Here I want to define a formula for calculating the value of hole radius. For example, 1/6 of the value of depth. So I make a copy from depth, then I can divide it into 6. Let's check it out. 20 centimeters. But guys, you may be wondering, why should we use the nested families? Since till now we have passed too many challenges in loading the nested family. I should say that using nested families is recommended actually, since it provides you with too many parameters. You can put everything under control. However, we were able to create at least 10 panels. At most 10 panels, I'm sorry. But I prefer to use a nested family, even for a single object, which is gonna be used inside another family. I load the nested family here. Right now the size of the radius is controlled. Here in edit types, as you can see, every parameters, all of them are associated to each other. If I maximize the value of depth, it affects on the panel depth and also the hole radius. Check this out. It seems that they are dependent to each other based on the defined formulas. Very well. Other examples about the creating chandeliers is creating the branches of the chandelier, then load them there as a nested family. We can model the main part and then the branches separately, and then we can load the branches there and then duplicate them. For example, about creating or modeling the doors, we only create the frame of the door. Other parts of the door, for example, the handles, the panels, these are considered as the nested families, since these families should be moved with each other. Now, there are too many cases that can be exemplified. Anyway, here we got the loaded panel with the hole, as you can see. I wanna move it, and preferably when you are moving the panel, uncheck the option of disjoin, since it is possible to just dissociate the specified families for the panel. The associate families may be disjoined, so that it may cause us problem because it removes the constraints and also the locks. I place it right here by this way. Check it out. We got the lateral walls and the shelf, or the panel actually. We got extrusions in the lateral walls and the panel with the hole or opening. Until now everything is okay. Don't forget to associate the parameters. Then the panel here is ready to be duplicated or to be arrayed. Actually, these were the rules and principles that you should know while creating the parameters, creating the families by using nested families. Watch the next session.